Q-qPCR software tutorial, Absolute Quantification Analysis. In this video, we will show you how to quantify the unknown concentration of a sample using the Absolute Quantification Analysis option of the Q-qPCR software. Absolute quantification uses a standard curve generated with samples of a known quantity. The standard curve feature allows you to determine the efficiency of an assay by using a dilution series of known samples. For this run, we will be quantifying next-generation sequencing libraries using the Spark Universal Library Quant Kit prior to sequencing. Before starting, make sure you have named your standards and samples and selected the sample type correctly. Select Standard for all your standards and annotate the given concentrations for each of them, ensuring you have the right dilution series. Select the appropriate units to report in or type in your own. Select Unknown for the samples with unknown concentration. Finally, make sure you have linked the samples to an assay. To start, under Analysis, select Absolute Quantification. Click on the plus button to choose the target you want to analyze. For this run, we will be quantifying NGS libraries using the Spark Universal Library Quant Kit prior to sequencing. Our target is Spark NGS. The analysis graph will plot CQ values on the y-axis against the log of the given concentration on the x-axis for each standard. A line of best fit is generated for the data plot. Standards are shown as blue dots and unknowns as red dots. The cycling analysis is used to determine the CQ values for the standard curve. Therefore, cycling analysis is automatically paired with and will appear beneath the absolute quantification analysis in the navigator bar. You can use cycling analysis to make modifications to analysis parameters, such as method, or ignore cycles before. Back into our target under Standard Curve Characteristics, the software reports the equation that includes the gradient of the line and the y-intercept, the efficiency that is calculated based on the slope of the line, the r-squared value that is the measure of the percentage of data that matches the hypothesis that the given data form a standard curve. A value of greater than 0.98 is typically a good r-squared value. The standard curve results include the quantification cycle, or CQ for individual standards. The given concentration is the value annotated in the samples editor. The reported units are also displayed in the column heading. The calculated concentration is an adjusted concentration for an individual standard based on the line of best fit. The percentage variation is the percentage difference between the given and calculated concentrations. The lower the number, the better. The sample results table reports the calculated concentrations for each unknown sample. The CQ values for each sample are also reported. We recommend using the Spark Universal Quant Calculator tool from our website to determine the specific concentration of the NGS libraries. This tool will generate a standard curve using the standard CQ values obtained from the run. Finally, enter the dilution, the average fragment length, and the CQ values of your libraries to obtain the concentration of undiluted libraries. In this video, we have shown you how to use the absolute quantification option to generate a standard curve and calculate your sample's concentrations. For more information about absolute quantification analysis, please contact the Quanta Bio team.